Hello everyone and welcome to this Unreal Engine 5 tutorial. My name is Karthik and today we will be building a reusable interaction framework by creating a complete door and key system. For this tutorial, I'll be using Unreal Engine 5.8. Although the workflow you'll see can also be applied to other versions of Unreal Engine 5. Throughout this lesson, we will explore several core blueprint concepts, including blueprint inheritance, blueprint interfaces, timelines, instance editable variables, and validated gets, while learning how they work together to build a reusable gameplay system. Rather than creating a door that's designed for just one situation, we will build a flexible interaction framework that can easily be expanded to support switches, buttons, drawers, pickups, elevators, and many other interactable objects. I've already created the project and imported the assets we will be using, so we can spend our time focusing on the gameplay systems instead of the initial project setup. Before we jump into Unreal Engine, let's take a quick look at how everything is going to work. A player will detect nearby interactable objects using collision. Whenever the player interacts with one of these objects, we will use a blueprint interface to send an interaction request. We will first use that system to create a door that the player can open and close. Then we will expand the same framework by creating a key that unlocks the door before allowing it to be opened. By the end of this tutorial, you will have built a complete door and key interaction system while gaining an understanding of the design principles behind it, making it much easier to apply the same techniques to your own Unreal Engine projects. Let's get into it. With our project ready, the first thing we're going to do is build our interaction framework. You might be wondering why not create the door first. The reason is quite simple. Throughout this lesson, we will create multiple interactable objects, such as doors and keys. Rather than writing the same interaction logic inside every single blueprint, we are first going to build one single reusable parent and then have all of our interactable objects inherit from it. This approach helps our project be organized, it reduces dependency work, and makes it much easier to later expand on this system. Let's get started. Inside the content browser, I'll create a new folder called interaction_systems. The reason I'm using an underscore here is because Unreal Engine does not like spaces in the names. That's why I replace it with underscore. And as for the folder itself, keeping related assets inside their own folder makes the project much easier to navigate and organize as they grow. At this folder, I'll create a new actor blueprint called BP_interact_master. This blueprint will act as the parent for every interactable object we create throughout this lesson. Let's open it. The first component I'll add is a sphere collision. This sphere will be responsible for detecting when the player is close enough to interact with an object. I'll rename it to Interact Sphere, so the purpose is immediately clear. Next, I'll configure its collision setting and change it to Overlap Only Pawn. We choose this preset because the only actor that should trigger the interaction is the player. And since the player is a pawn, this preset gives us exactly the behavior we're looking for. And it also ignores any unnecessary overlaps occurred from this actor. And that's all we need to do for now. With our interaction system officially in place, let's use it to create our first interactable object, the door. Rather than creating another actor blueprint from scratch, we'll create a child blueprint from our BP Interact master. So find your master blueprint, right-click on it, and click on Create Child Blueprint class. I'll rename this to BP underscore door. After opening it, the first thing you'll notice that our interaction sphere is already inside of this blueprint, even though we never added it in here. Well, that's because BP door inherits everything from our BP interact master. You can see it over there. This is called inheritance, and it's one of the core principles of the object-oriented programming language. A child blueprint automatically inherits all the components, variables, functions, event graph. Everything that the parent child has is inherited by a child blueprint. This allows us to build a shared functionality once and reuse it across multiple objects. Now let's turn this blueprint into an actual door. I've already imported my necessary assets. To add them in our blueprint, there are two approaches. We can create a static mesh component and add whatever meshes we need in the details panel. Or we could just select our static meshes and drag them on top of our components panel, which will automatically add them. I often use the second approach since it's a lot quicker. Because these assets were imported with their pivots at the correct locations, there is no need for me to modify them. Next, let's resize our interaction sphere so it comfortably surrounds the doorway. The exact radius isn't important as long as it overlaps the door. I'll also position it at the center. And I am happy with that. With that done, I'll drag our door blueprint onto the level, which is inside the interaction system folder. If I hit play and walk up to the door, nothing happens. And that's completely expected. At this point, we've created our first interactable object and defined the area where the player can interact with it. What we haven't done is give our player a way to communicate with the door. At the moment, our player has no way of communicating with the door. One solution would be to add a cast directly to the BP door whenever the player wants to interact with it. While that works, it also tightly couples our player to the specific blueprint. And as our game grows and we introduce new interactable objects like keys, switches, doors, we'll have to keep adding more cast for every new object we create. That quickly becomes difficult to maintain. Instead, we're going to use a blueprint interface. A blueprint interface allows different blueprints to communicate with each other without needing to know what exactly the type of object we're talking to. As long as a blueprint implements the interface, we can send a message and let that blueprint decide what to happen. Think of it like pressing a doorbell. You don't need to know who's inside the house or what they're doing. You simply press the button and whoever's inside decides to perform an action. A blueprint interface works in a much similar way. The player sends an interaction request and each interactable object decides what to do with that request. To create one, navigate to your interaction system folder, right-click. Under Blueprints, you'll find Blueprint Interface. I'll name it BPI_interact, as in Blueprint Interface _interact. Unlike a normal blueprint, a blueprint interface doesn't contain components, variables, or even an event graph. Instead, it simply defines a set of functions that the other blueprints can implement. Right now, we only need one single function. I'll rename the existing function to interact. Notice that there isn't anywhere to write the actual logic for this function. That's intentional. A blueprint interface only defines a function that exists. The actual implementation of that function happens inside the blueprints that use the interface. Now that we've created our interface, we need to tell our interaction blueprint that it supports it. Open your master interaction blueprint and then go to class settings. Under the interface section, click on the drop-down and add BPI_interact. Once we compile the blueprint, the interact function becomes available inside our blueprint. We won't implement its behavior just yet though. First, we need to teach our player how to find nearby interactable objects and send the interact request to them. Open your player character blueprint. To detect when the player wants to interact with an object, we will use the left mouse button. So inside your event graph, right-click and search for left mouse button. Whenever the player presses their left mouse button, this event will trigger. So whenever the player clicks the left mouse button, we first need to determine whether there's an interactable object nearby. Since every interactable object inherits from the BP interact master, and every one of those objects uses an interaction sphere, we can take advantage of Unreal Engine's overlap system. We will begin by getting all currently overlapping actors from the player's capsule component. So drag in your capsule component, and from it, search get actors, which will give you get overlapping actors. This node returns an array containing every actor currently overlapping the player's capsule. Of course, not everything in that array will be necessary for something that the player can interact with. So the next step is to filter those results. For the class filter, we will specify BP interact master. This tells Unreal that we're only interested in actors that inherit from a parent interaction blueprint. Every single interactable object in our project will inherit from this parent. This single filter will automatically work for our doors and keys as well. Now that we have our filtered array, we need to process each actor it contains. To do that, we will use a for each loop. So drag out from your array and search for each loop. This loop runs once for every actor in the array, allowing us to perform the same logic for each interactable object currently stored in that array. Inside this loop, we will call our interact interface function for the currently active actor. Notice that we're not casting to BP door directly. Instead, we are sending an interact message through Blueprint interface. This is one of the biggest advantages of using interfaces. The player doesn't need to know whether it's interacting with the door, a key, or any other interactable object. It simply sends an interaction request, and if the object implements our BPI interact interface, it will decide how to respond to that message. This keeps our blueprint simple, reusable, and independent of any specific interactable object. Before we continue, I will quickly save my work. You'll probably notice me doing this every now and then. It's become a second habit of mine over the years. I unconsciously save the project every few minutes. It only takes a few seconds and it can save you a lot of frustration if something unexpected happens. With that done, I'll hit compile to check if the blueprint has any errors and everything is correct. The one thing that we're missing now is telling our door what to do once they receive the interaction request. Let's open our door blueprint. Since we previously added the BPI interact to the master blueprint, we now have access to its interact event inside our door blueprint. To use it, simply double-click on it and it will automatically be added to your event graph. This event will be executed whenever any other blueprint sends an interact message to this door. For now, let's keep things simple. We will connect the interact event to a print string node displaying the message, door interacted. This gives us a quick and easy way to verify that our interface function is working correctly before we move on to animating the door. Before testing, I'll save my work again. As mentioned earlier, I have a habit of saving every few minutes. It's basically my second nature. When I walk up to the door and click the left mouse button, we can see the message appear on top left of the screen. This confirms that everything is working correctly. Our player character successfully detected the nearby interactable object, sent an interaction request through Blueprint interface, and the door successfully received that request. Those are three things we did. Although all we're doing right now is printing a text on the screen, this is actually an important milestone. We've verified that the communication between our player and the door is working exactly as intended. From this point onward, we can replace the print string with an actual gameplay logic. There are several ways to animate objects inside Unreal Engine, but for simple movements like opening a door, one of the most common and beginner-friendly tools is a timeline. A timeline allows us to smoothly change a value over time instead of instantly jumping from one value to another. Let's create one now. I'll delete the print string, right-click on the event graph and search for timeline. Now click on Add Timeline. Double-click on the timeline to open it. Inside it, we will create a new float track and rename it to Alpha. This float track will control how far through the animation our door is. I'll add 2 keyframes in here. The first keyframe will be at 0 seconds, containing a value of 0. And the second keyframe will be at time 0.5 seconds with a value of 1. While I'm at it, I'll also limit the timeline length to 0.5 seconds as well. And I'll click on the horizontal and vertical alignment to make my curve be visible in the graph. Now this curve means that over the course of half a second, our alpha value will smoothly increase from 0 to 1. Now let's return to the event graph. Whenever the interact event is called, we'll connect the play pin to our timeline. As the timeline plays, it continuously outputs the alpha value we created. We can use that value to smoothly rotate our door. To do that, we'll use a node called Lerp Rotator node. A lerp, which is short for linear interpolation, smoothly blends between two values based on an alpha. When the alpha is 0, the output is exactly equal to the first value. When the alpha is 1, the output is exactly equal to the second value. Any value in between gives us a smooth transition from one to the other. For the A input, I'll leave the rotation value to 0, which represents the door's closed position. For the B input, we'll use a rotation of 90 degrees in the Z-axis, which will be our open position. After that, I will connect our alpha curve value to the input alpha of our lerp node. Finally, you can grab your door mesh and use the set relative rotation node and connect it to the on-update of your timeline. We'll plug in the output of a lerp node to the input of the new rotation. Notice that we're using set relative rotation instead of set world rotation. The reason for this is that the door is attached to the blueprint. By rotating it relative to its parent, the door will always open correctly no matter where the blueprint is placed in the level. Now let's save our work, compile the blueprint, and give it a test. I'll press play, walk up to the door, and click the left mouse button. As you can see, the door now opens smoothly instead of rotating instantly. The timeline is controlling the speed of the animation, while the lerp is calculating every intermediate rotation between the closed and the open positions. At the moment though, the door only opens once. If we try interacting with it again, nothing happens. That's because every time we interact with the door, we are always telling the timeline to play from the beginning. Instead, we want the door to remember whether it's currently open or closed and decide what to do based on its current state. To do that, let's create a new Boolean variable called isOpen. By default, the value is set to false, meaning the door starts in its closed state. Whenever the player interacts with the door, we will first check the value of isOpen using a branch node. If isOpen is false, that tells us that the door is currently closed. Before playing the timeline, we will set the isOpen variable to true. This updates the door state to indicate that it is now open. After that, we will connect the execution pin to the play of the timeline. If isOpen is already true, we'll follow the other execution path. First, we will set the isOpen to false and then connect it to the reverse pin of the timeline, and then connect our branch to the interact logic. As the timeline plays in reverse, the alpha value smoothly decreases from 1 back to 0, rotating the door back to its closed position. By updating the Boolean before playing the timeline, the variable always represents the state we are currently transitioning into, allowing the next interaction to take the opposite path through the branch. Before continuing, I'll save my work and then compile the blueprint. This time, when I interact with the door, for the first time, it opens smoothly. If I interact with it again, the timeline plays in reverse, smoothly closing the door. Each interaction simply toggles between the value of isOpen and allowing the same interaction to both open and close the door. At this point, we have a fully working interactive door. The next step is to add a locking system so that the door can only be opened after the player has collected the correct key. We will begin inside BP door. First, let's create a new Boolean value called isLocked, and by default set its value to true, meaning every door starts in a locked state. Next, let's open our blueprint interface. So far, our interface contains only one function, that's our interact interface function. We'll add another function and call this unlock. Just like before, the interface only defines that this function exists. We will implement its behavior inside the blueprint that uses it. Now let's return to BP door and hit compile. Under interfaces, because the BP door already implements the interact interface from its parent file, there is no need to add the interface again. Double-click on the unlock to add the function to our event graph. Whenever this event is called, all we need to do is set the isLocked variable to false. Now let's prevent the player from opening a locked door. Inside the interact event, before checking whether the door is open or closed, we will add a branch node using our isLocked variable. The shortcut to a branch node is holding down the B key and pressing the left mouse button. Then we can attach our isLocked variable to the Boolean check. If isLocked is true, we simply stop the execution. If isLocked is false, the execution continues into the door open and close logic we built earlier. With the door finished, we can now create the key. Inside the interaction system, right-click on the interact master and create a child blueprint called BP_key. Since it inherits from the BP interact master, it already contains the interaction sphere and already implements BPI interact, so there is no need for additional setup. I'll drag in the key mesh into the components panel and make sure the interaction sphere overlaps the key completely. Create a new variable called door reference. Set its type to bp_door, and then make it instance editable. Making a variable instance editable allows us to assign a different door to each individual key from the level. This makes the system much more flexible, since the same blueprint can be reused for multiple doors. Inside the interact event of BP key, drag in the door reference variable and use a validated get on it. Using a validated get allows us to safely verify that the door has been assigned before trying to access it. If the reference is valid, we will call the unlock interface function on that door. Once the door has been unlocked, we will use a destroy actor node to remove the key from the level so it can only be collected once. Before we continue, I'll save my work, then let's compile the blueprint. Now let's place everything in the level. I'll drag the BP key into the scene and select it. Because the door reference is marked as instance editable, now it appears on the details panel. I'll use the eyedropper tool to select the door that this key should unlock. And now let's test our system. I'll walk up to the door and try to interact with it. And nothing happens, because the door is still locked. Next, I'll interact with the key. The key calls the unlock function on the assigned door and then destroys itself, indicating that it has been collected. Now, if I return to the door and try to interact with it, it opens exactly as expected. And with that, we have successfully built a complete door and key interaction system. Throughout this tutorial, we have created a reusable interaction framework while exploring several important Unreal Engine concepts, including blueprint inheritance, blueprint interfaces, timelines, instance editable variables, and validated gets. More importantly, we've seen how these individual features work together to create gameplay systems that are flexible, reusable, and easy to expand. Although we've used this framework to build a door and key system, the same architecture can be easily adapted to support virtually any other interactable object in your project. Thank you very much for watching, and I hope you found this tutorial helpful.